Welcome to my presentation. Today I'll be discussing on electric braking of three-phase induction motor. Generally speaking, we need braking in order to stop the motors. So to stop a motors, we can have two options. We can either have electrical braking or mechanical braking. Nowadays, electrical braking is gaining popularity over mechanical braking because it has various advantages, such as it does not need much maintenance as mechanical braking, and it is also efficient and very fast. So under electric braking we have various methods. We have regenerative braking method, we have plugging braking and dynamic braking. However, in this presentation I will be focusing on plugging braking of induction motor only. So before learning how the plugging braking of induction motor is achieved, let us see how the three-phase induction motor works. As the name suggests, three-phase induction motor will have the three-phase supply, and three-phase supply is electrically 120° in phase delay with respect to each other. So in this diagram you can see like there is a three-line supply given to this induction motor, the line A, line B and line C, and this graph here shows the phase difference of each of this supply line. So due to this phase difference, the rotating magnetic flux or rotating magnetic field will be produced in this induction motor. So what does this rotating magnetic field does? Rotating magnetic field rotates the router, and in this diagram you can see the curve projection here is the magnetic field, and this component is a rotor. And if you can observe closely, the direction of the rotating magnetic field and the rotor is same. However, there will be the difference in their speed. The speed in which this magnetic field rotates is known as a synchronous speed, and the speed at which this rotor rotates is known as the rotor speed. The synchronous speed will be always leading the rotor speed. Through this relationship we can define one parameter known as slip, and the slip is given by the formula ns minus nr divided by ns. Here ns represents the synchronous speed and nr represents the rotor speed. Now we will move on with the plugging braking method. Now we have already seen how the induction motor works. Now we will look into how we can apply braking in this three-phase induction motor, and for that we will choose a particular method that is known as the plugging braking method. We have three braking methods, so out of three we are choosing plugging braking method. So in this braking method, what do? We simply change the phase sequence of the induction motor in order to apply the brake. So let me explain in detail. So let us assume that this stator has a three-phase supply, right? So the sequence of the supply is RYB, or we can also say like the phase sequence is RYB. During this phase sequence, let us say the direction of rotating magnetic field is in clockwise direction, and the torque produced will also be in this direction of the rotating magnetic field, that is clockwise direction. However, let me erase this. However, if we change the phase sequence, now this first line is connected to this line and this second line is connected to the first branch of this line. Now what did we do? We simply change the phase sequence of the input supply. If we change the phase sequence, it will result in the change in the direction of rotating magnetic field. Before, the magnetic field direction was the clockwise direction. In the clockwise direction, after the changing the phase sequence, now the direction of rotating magnetic field will get reversed. That is, now it is in anti-clockwise direction. When the direction of the magnetic field changes, the torque will also be in the direction of a new magnetic field direction, and this reverse torque is basically used to brake the induction motor. Now we will derive the slip of plugging braking. We know that normal slip is given by this formula, and we assume this formula to be equation 1, and the braking slip is given by this formula. The only difference here is there is a negative sign before NR, whereas here we have a positive NR. The reason for this negative sign is the direction at which the rotor rotates is not same as the direction at which the rotating magnetic field rotates. When the brake is given, they will be the rotor and the magnetic field will be rotating in opposite direction. That is why, in order to represent the difference in direction, we have given negative sign here. And when we consider the negative sign before NR, we will get this equation, and I'm considering this as equation 2. Now if we add equation 1 and equation 2, the resultant equation we get is SP is equal to 2 minus SN. This SP is a slip of plugging braking, and SN is the normal slip. So normal slip and the braking slip relates to each other through this equation. The next, we will see the torque versus speed characteristic of induction motor during the plugging braking. This is a graph which shows the torque versus speed characteristic in 4 quadrants. This first quadrant, it is for forward motoring, and in this first quadrant the motor will function normally, or we can say like the operation of motor will be in normal condition. In a sense, like the motor will be in forward condition, forward motoring condition. Let us assume like the motor will start from this point. So this is the initial torque the motor has, and slowly the speed of a motor increases along with the torque, and at point A the motor will stabilize, which means the speed of rotor will be maximum. Now in this condition, if we apply the reverse or the plugging braking, this whole characteristic curve will flip in this manner. This is because when we apply the braking, the direction of rotating magnetic field will change and produces the reverse torque, which is given by point B, and the braking torque, total braking torque required for any induction motor to stop is equals to torque A plus torque B. This is torque A, uh, and this is torque B. This is the sum of the torque A and torque B is known as a braking torque. And when the braking torque is applied, the speed of a motor will gradually decrease, and at point C the speed of a motor will be 0. During that condition, we can either remove supply or we can apply mechanical brake. If we don't remove supply or apply mechanical brake, the motor will continue to rotate in reverse motoring condition. That means the direction of the rotating motor will change and it will start to rotate in a reverse order. So from this torque versus speed characteristic, we can visualize or analyze how the plug-in braking can be applied to induction motor to stop it. Thank you.